This is the Life Water, and this new Oasis product is the most valuable liquid in the world. One drop could let people live 10 years longer. Due to its high significance, our company decided to put this in the safest place.
Oh my god, what is this? This is a warning sign. There must be some problem near our storage. And the life water is there. I have to check it. It looks fine. Oh my god, there's a hole there. It's leaking. And the machine showed me that it's already leaked for 3 minutes. The current leaking speed is 3 gallons per minute. I need 3 more minutes to fix this. Let me use my machine to calculate the acceleration. Oh, it's giving me this function of the acceleration. I need to know how many gallons left after I fix it. Oh, this is a calculus problem. I've learned this in Mr. Schnur's class. Oh, I know how to fix it.
Okay, so it's my turn now. So I'm Simon Spring, and I'm gonna take over his slot. So let me show you how do I fix this problem. So the only things we know now is the function of acceleration, but we have to know the leaking volume, the final leaking volume. So first of all, we have to know how do we get the final leaking volume from only the function of acceleration. So we have learned the relationship between the acceleration velocity and the volume in calculus class, which is the volume represent the original function. So the volume represent the original function, and the leaking speed represent the first derivative, and the acceleration represent the second derivative. So the only thing we have to do is to antiderivative the acceleration first to get the function of velocity. So in order to get the function of velocity, we have to use U substitution, because the function of acceleration is a composition function. So we make the U equals x plus 2. So du is just dx. So then we can now find the function of the velocity, which is antiderivative -20 u squared du, and then we got 20 over u plus c, which is x plus 2, 20 and plus c. But we have to figure out what is c. And so now we have to use the information that shows on the machine that near the liquid. So it's at the current speed at the third minute is 3. So we know when x equals 3, the velocity also equals 3. So we substitute this into the function, and we got 20 over 3 plus 2 and plus c equals 3, which means c equals -1. So then we got our final function of the leaking velocity, which is 20 over x plus 2 minus 1. So now we draw this function in decimals, which is this graph, and In order to find our final volume, we have to know the bounded area between x equals 0 and x equals 6. So because Simon found the liquid was leaking at 3rd minute, but he also need extra 3 minutes to fix it. So as a result, we have to find the integral between 0 and 6. And so the only thing that Simon need to do now is calculate the integral in his calculator.
Alright, so what am I gonna do is to open a new document and add graphs. According to my brain, the final velocity function is given by 20 over x plus 2 minus 1. So I have to put 20 over x plus 2 minus 1. And this is the function given. And I have to zoom out because the function is too small. So zoom out this area. And this area is given. And I have to calculate from 0 to 6 the bounded area, which is the integral, and is also the volume that leaked. So what I'm gonna do is open menu, go to analysis and analyze graph, and go to integral, and then you can plug in the x coordinate you want, which is 0 and 6, and then you will get an integral from x equals to 0 and x equals to 6. And this 21.725 is the final volume that leaked from the bottle. Oh, I finally fixed it.
Oh, this is a calculus problem. I've learned this in Mr. Schneer's class. I know how to fix it.